Welcome back to the Deep Dive. If you're watching the tech world, it's clear the age of AI isn't on the horizon. It's firmly here.
Absolutely. It's moved way past being just a novelty.
Right. It's now this fundamental pillar, quietly running things behind the scenes like your assistant schedule or even optimizing, these massive global supply chains.
And the sources you shared with us, they really pull back the curtain on how this works. They give this incredibly detailed, almost minute-by-minute view of the nonstop 24-hour life of a complex, large language model.
We're calling this one Aurora, just to give it a name.
Aurora, right, and it
Yeah.
operates continuously.
Okay, so let's get into it. Our mission today is really to demystify Aurora, isn't it? We want to get past that idea of the AI black box.
Exactly. See what this complex system, which is really just data and algorithms, let's be clear, actually does.
And we're going to track it chronologically, using its MLOps phases throughout a typical day.
MLOps, machine learning operations. It's basically the engine room that keeps these AI models running, updated, and doing their job reliably out in the real world.
So, structuring it this way, following the clock UTC, the universal clock should give us a narrative.
Yeah, a way to sort of narrativize this huge ongoing effort. The goal is to show you, the listener, that this isn't magic. It's an incredibly complex, iterative system that needs constant maintenance.
Precisely. And understanding this demanding cycle, this continuous loop, it's kind of a shortcut, isn't it, to being genuinely informed?
How so?
Because it shows not just the amazing capabilities, but also, crucially, the built-in limitations, the trade-offs that are happening constantly.
Right. Every single day.
Okay, let's jump in. Midnight UTC. So we start with madrugada, the deep, early hours. You describe this as Aurora's digital introspection.
It's a critical window, these first 6 hours, all about data ingestion and refinement.
Existential work, you said. Like, if it doesn't do this properly,
It quickly becomes outdated, inaccurate, irrelevant even. This phase is absolutely fundamental.
and it's dealing with just staggering amounts of information.
No, it's monumental. We're talking petabytes daily, fresh information flowing in from everywhere. Real-time news, academic papers, social media, open data sets, you name it.
Okay, but it can't just be hoovering it all up, right? There's that saying, garbage in, garbage out.
You hit the nail on the head. Simple collection isn't enough. This involves really advanced data pre-processing.
Like what, specifically?
Cleaning the data, getting rid of duplicates, deduplication, and standardizing formats, which is called normalization. Think of it like prepping ingredients in a massive kitchen, sorting, scrubbing, making sure everything's usable.
And if it doesn't filter properly, if it gets overwhelmed,
Then you risk information overload internally and kind of AI overwhelm where the model can't effectively prioritize what's relevant later on.
what's really striking, according to the sources, is how this quiet technical work way back here in the dead of night affects what happens later, especially with bias.
Absolutely critical. This prep phase is the very first line of defense against embedding or amplifying errors.
Because the historical data itself might be flawed.
Exactly. It might have biases or be unbalanced, unrepresentative. If Aurora just learns from that without correction, it'll reproduce those errors. So it uses technical fixes like class rebalancing, anonymization protocols to actively manage those flaws in the data it ingests.
Trying to stop skewed or unfair answers before they even happen?
That's the goal.
Give us a quick example. What happens if madrugada goes wrong in the real world?
Okay, picture a financial AI trying to predict market trends. If its madrugada phase fails to process, say, some major overnight political news properly, it might just rely on older data.
So it's working with stale information.
Right. Then, boom, some unexpected event happens at 10 a.m. UTC. The AI's predictions are suddenly useless, maybe leading to bad trades or faulty analysis. This is also why traceability is key here, knowing exactly where data came from for audits and such. It's constantly hardening itself against becoming obsolete.
Okay, so if the world starts waking up, user traffic climbs. We hit mañana, 06.00 to 12.00 UTC. This is the training on continuous learning phase. Fine-tuning, you called it. How is this different from just ingesting data like before?
Well, if madrugada was stocking the pantry, mañana is where the chef actually practices the recipes. This is where the model actively modifies its internal structure based on that newly ingested data.
Okay.
It's an iterative process driven by complex optimization algorithms. The most famous one you hear about is gradient descent.
Gradient descent. Sounds very technical. Can you give us an analogy?
Sure. Imagine Aurora is blindfolded on a hilly landscape. That landscape represents all the possible errors it could make.
Okay.
Gradient descent is like the algorithm telling it which way to step always downhill to find the lowest point, the point of minimum error. It's constantly adjusting billions of connections, these internal parameters, within its neural network.
To make better predictions next time.
Exactly, refining those connections.
I like that analogy. It really highlights the constant adaptation.
Yeah.
It's not like it learns once and it's done.
Not at all. It's alive in a computational sense. It has feedback mechanisms built in. So if users suddenly start asking a lot about, say, a complex new topic like ethical AI frameworks,
Something new and specific.
right, Aurora can quickly integrate specialized data sets on that topic. It deepens its knowledge on the fly, balancing the need for depth with the need for computational speed.
Speaking of complexity, the sources brought up things like 6G networks. Training an AI to optimize something that fast must put enormous strain on the physical systems, right?
Oh, absolutely. Continuous training like this, especially for industrial applications like optimizing telecom networks, involves distributing massive computational loads, usually across huge clusters of GPUs, often spread out
I'm glad we
geographically,
could spread them out.
to minimize latency, the delay, and maximize how adaptable the network is. It's a constant sort of arms race between the computational demand and the physical hardware resources available.
Which brings us right back to that huge elephant in the room, energy consumption.
Yep.
All that intense training, adjusting billions of parameters. It must have a monstrous energy footprint. The sustainability challenge isn't theoretical here, it's baked into the schedule.
It truly is, and the sources really emphasize this. Mitigating that impact requires concrete steps during this training phase. Things like model compression.
Uses like finding ways to store the knowledge more efficiently.
Exactly, using fewer computational bits, or deploying newer, more energy-efficient hardware. If Aurora can learn the same amount but use, say, 10% less energy than yesterday, that's a major operational win.
Right, midday rolls around. Mediodía, 12.00000 UTC. Now, Aurora is fully interacting with the world. This is the pulsing heart, you said. Inference.
This is it, peak performance time, transforming thousands, maybe millions, of human queries into useful responses, and doing it in milliseconds.
How is inference fundamentally different from the training we just talked about?
Okay, training is about learning the rules, changing the model's internal wiring. Inference is when the learning pauses, the structure is sort of locked for a bit, and the model applies those learned rules at massive scale and incredible speed.
And this relies on those transformer architectures we hear so much about.
Primarily, yes. Those attention mechanisms within the transformers are key.
Okay, give us the simple version. How does it generate text so fast? What's actually happening?
Think of it like a super sophisticated guessing game, like 20 questions but played millions of times a second. You give it an input, a word or a phrase, a token.
Okay.
Aurora processes that, then rapidly calculates the probabilities of what the next most likely token should be, then the next, and the next, stringing them together to form the most coherent, contextually relevant sentence or paragraph.
And the value here isn't just speed, it's relevance, quality.
Absolutely. Speed is useless if the answer is wrong or irrelevant.
How does that translate during these peak hours? What kind of things is it doing?
Well, the sources give compelling examples. Aurora might generate a highly personalized workout plan for someone, meshing biomechanics with their stated preferences and limitations.
Okay.
Or, in a business context, maybe it helps a legal team by instantly pulling up relevant international data privacy regulations for a tricky ethical question they're debating. It acts as this incredibly fast information hub.
What about surges? Like a major news story breaks and suddenly everyone is asking about it at once. How does it cope?
Scalability is everything here. For something like a global customer service chatbot, Aurora has to handle maybe thousands of simultaneous conversations.
Without slowing down.
That's the goal. The system dynamically scales up, grabbing more computational resources instantly to keep latency low for everyone. But, like you hinted at earlier, this speed demands perfect harmony.
Between the hardware and the software.
Exactly. Cutting-edge chips and perfectly optimized code. There's just no margin for error or delay during peak inference.
So if it's always optimizing for speed and relevance during this intense period, is there a trade-off? Does aiming for instant answers sometimes mean sacrificing depth?
That's the constant tension, yes. The sources do confirm this. Optimizing purely for speed, especially when the system is distributed globally, can sometimes mean it simplifies the problem slightly.
How so?
Well, If a query needs really deep, maybe cross-disciplinary thinking, the pressure for a fast response might lead Aurora to give the most probable answer, which might not always be the most nuanced or comprehensive one. The quality of Mediodía really depends heavily on how good the training was back in Mañana.
Okay, the peak rush starts to subside. The world quiets down a bit, electronically speaking. Aurora enters Tarde, 1800 to midnight UTC. You called this the reflective closure.
It's like a self-assessment period, wrapping up the day, monitoring performance, and prepping for the next 24-hour cycle to begin again.
And this is where human oversight really kicks in strongly. MLOps engineers.
Yes, the control systems, often monitored and guided by humans, are very active here. Real-time logs are capturing everything: error rates, memory usage, patterns in the queries people made,
Why track all that so closely?
to spot anomalies early. Anything unusual. That could range from spotting attempts by bad actors to manipulate the AI adversarial attacks.
People trying to trick it or break it.
Exactly. Or it could be detecting something more subtle, like data drift.
Data drift. That sounds important but a bit abstract. What does it mean practically for Aurora?
It means the ground is shifting under its feet, essentially. If the new data coming in during the next madrugada is starting to look different from the data it was trained on, maybe new slang emerges or a government changes terminology,
I see.
then Aurora's existing training starts to drift out of sync with reality. If that drift isn't caught and corrected here in Tardy, the model could start giving weird or nonsensical answers tomorrow.
So the system flags these issues, and then what? Does it try to fix them automatically?
Often, yes, there are auto adjustments. A key one is called pruning.
Pruning. Like gardening.
Kind of. Imagine Aurora's huge neural network, billions of connections. But maybe some of those connections, those weights, haven't actually been useful for weeks.
Deadwood, basically.
Pretty much. Pruning automatically removes those unnecessary weights. It's like clearing out clutter. This makes the model smaller, computationally lighter, faster, and more energy efficient for the next day's training cycle.
That makes sense.
Yeah.
But this idea of auto adjustments, does it ever get it wrong? Could it prune something important by mistake?
It's a calculated risk. That's precisely why human feedback loops are vital in this phase. The monitoring logs are constantly reviewed by engineers to make sure these optimizations, like pruning, aren't accidentally making the AI dumber, essentially.
Okay.
Aurora also uses this time to analyze usage patterns globally, to try and predict demand for the next day, scaling up infrastructure proactively if needed. This whole phase really underscores the iterative nature of AI. It's never finished. It's always transitioning, preparing to renew itself. #hashtag synthesis and key challenges.
So we've tracked the whole 24-hour cycle, from that deep data dive at midnight, through training, peak performance, and now this nightly reflection and optimization. It's clear Aurora is this incredibly dynamic ecosystem.
Yeah, a collaboration between data, algorithms, hardware, and essential human oversight.
And the value proposition, boiling it down.
It's about amplifying human potential, fundamentally. Aurora demonstrates how AI can speed up diagnoses in medicine or help manage complex financial risks. It's an efficiency engine, but one that needs careful steering.
But this nonstop operation consumes vast resources and throws up some really serious problems. The sources you shared zeroed in on 4 key challenges, not just technical glitches, but foundational issues.
Right. They demand serious attention. Let's start with the purely technical challenge. Aurora needs more and more data to stay accurate, but that creates huge bottlenecks.
Energy and storage, right?
Exactly. We just can't keep building infinitely larger models with current tech. It's unsustainable. This pushes the need for breakthroughs in areas like, say, quantum computing, or perhaps federated learning ways to distribute the workload more efficiently without bottlenecking.
Okay, challenge number 2, latent data flaws. Even with the best cleaning efforts back in Madrugada, historical data often contains hidden biases or isn't fully representative.
And that risks creating systemic errors in how the AI operates. It means there has to be this ongoing, rigorous commitment to auditing the models, diversifying the data sources.
Because if it only learns from one perspective,
Its ability to interact accurately with the whole diverse world is compromised. It's an engineering problem tied directly to accuracy and fairness.
then there's the regulatory challenge. Aurora operates globally, instantly, but laws and regulations don't.
No, they definitely don't.
So ensuring AI decisions are traceable, especially in critical systems like that 6G example, often bumps up against different countries' rules on data privacy or data sovereignty.
Precisely. Governments are playing catch-up. There's no single set of rules. So companies running systems like Aurora face this constant puzzle. How do you innovate quickly but stay compliant in dozens of different legal systems? We urgently need more unified international standards.
A common framework. Okay, and the final challenge identified was perceptual, how we see these systems.
Yes, the tendency to anthropomorphize.
To treat Aurora like it's, well, human-like, maybe even conscious,
Exactly, and that inflates expectations massively.
which is dangerous because
Because if people don't understand that Aurora is fundamentally a probabilistic machine, incredibly sophisticated, but still predicting likelihoods based on data, then when it inevitably makes a mistake or shows its limits, that inflated expectation can lead to a rapid loss of trust. We need to be realistic about what it is and isn't. Honesty about its limits is key for public confidence. Outro. So when you look at Aurora's whole day, its success really hinges on governance. Finding that balance between pushing innovation and maintaining solid, ethical, operational principles, the cycle itself proves constant human vigilance is required.
yeah, it seems the real leap forward for AI isn't just making the tech itself smarter, but figuring out how we integrate it intelligently. To enhance what humans do, not just replace it. Aurora's day is this constant tightrope, walk speed versus accuracy, scale versus cost, potential versus risk.
And the sources really hammer home the need for collaboration. Engineers, ethicists, regulators, they all have to work together.
So let's leave you, our listener, with this thought. Given Aurora's relentless, exhausting cycle of learning, making mistakes, and correcting itself, what responsibility do you have? How can you stay informed about those unavoidable trade-offs? The energy used versus the problem solved, the speed gained versus the nuance potentially lost that are shaping the next generation of AI right now.